So we did a simulation earlier with carts coming together, looking at collisions, and now we're going to have a simulation where the carts are going to go apart, and this simulates an explosion. So the carts are together, they're in effect one object, and then they become two objects, more than one object. So just going to show you a few examples, and then we can see all the results together in a table. So let's see if we have the masses of the carts are the same. The blue cart here is 1.5 kilograms, the red cart was also 1.5 kilograms. What happens if there's an explosion in the middle of the two carts here and they move apart? Will they move apart with the same velocity? Of course they do. Of course they do move apart with the same velocity. And in this case, that would be measured as 20 centimeters per second, or 0.2 meters per second. And so we'd be able to calculate what the momentum is of that. Now, we see that when we explode them, we get the same speed, but the velocity of one of them is going to be in the opposite direction to the other. So, for example, if the blue one, we could say that has a positive velocity. It doesn't matter which one we say has a positive velocity. Let's say the blue one has a positive velocity, then that means the red one has to have a negative velocity. So it's not as if this momentum adds up to this momentum. What actually happens is this momentum of the blue cart will be positive and the momentum of the red cart will be negative. So they will add up to 0. They don't add up to a positive number. They add up to 0. And the momentum at the start is also 0. So let's have a look now if we change the mass. What happens if we increase the mass of the blue cart? Say we increase it up to 2 kilograms. And the red cart will keep as mass of 1.5 kilograms. So what do we get there? What do you think the prediction would be? Do you think the blue one's going to move off with a bigger velocity or a lower velocity, a smaller velocity? The red one moves off more quickly. Okay, the blue one moves off more slowly now. So you can see that the values have changed. The blue one's gone down to a lower value. But look at the numbers. If you multiply 2 by 15, what do you get? 30. What happens if you multiply 1.5 by 20? What do you get? 30. So the magnitudes are the same. The sizes, the relative size of the momentums are the same. It's just that one's going in the opposite direction. So the red cart again will have a negative momentum and the blue cart will have a positive momentum, but they'll both add up to 0. Let's reset it. Do we get the same momentum each time? So I'm going to keep the blue cart as 2 and take the red cart down just to 1 kilogram now. We can see that they explode and the red one moves off much more quickly now than the blue one. How much more quickly? It's got to be going more twice as quickly, because its mass is only half of the mass of the blue cart. So let's look at the momentum again. 2 multiplied by 15 gives 30. 1 multiplied by 30 gives 30. So remember, the red one's going to be minus 30. The blue one's plus 30. They add up to 0. Let's do one more. Explode this one. So we've got 2 kilograms on this side and 0.5 kilograms on this side. And see that the red one shoots off and the blue cart travels relatively slowly towards the left. So the momentum of the blue cart after the collision is now 2 multiplied by 15, which is 30, and the red one is 0.5 multiplied by 60, which is also 30. But again, the red one is negative, so negative 30, and the blue one positive 30. So they both add up to a total momentum 0, which is what you have at the start. It's stationary and there's no movement, so the momentum of the system is 0. So momentum is conserved and the principle is satisfied.